All right, so we're going to get started here. So I'm just going to do a brief introduction to the presentation here. I'm Daniel. I've been making games for quite a while. I do it as a hobby. I have also studied computer science. And today we're going to be doing an introduction to game development using a framework called processing. So this is a tool that's built around the Java programming language, and it allows you to easily draw things to the screen. And we're going to be using this to make a simple game to introduce some common concepts that are found in game development and how to solve problems related to related to game development. So to start off, who is this presentation for? This is going to be for people who have some programming experience. You know how to work with methods and classes, but you haven't made a game before, or maybe you have, but you've struggled to make a larger game because your programming your program becomes hard to extend, or if you're unsure how to start creating a project. And we're also going to be covering, like I said, common game development topics like collision detection, getting an enemy to follow a player, randomly spawning. So if you've made games before, or if you've used Unity, things like that, this workshop might not be the best fit for you. You might know some of these already, but you might learn something. So if you want to stick around, that's okay too. So going into this, you're going to be expected to know a couple of things, just a little bit of Java syntax. If you're not familiar with Java, that's fine, but like C#, very, very similar. And then basic programming concepts like variables, methods, and classes. We're going to be using these throughout the presentation today. So here's the up on the top, you'll find the link to processing. This is the framework or program we'll be using to develop our game here today. It makes it easy to draw images, play sounds, and we're going to be making a top-down shooter. It's going to be like a space shooter here. No, I'll pull up the game so you guys can see what we're making here today. So it's pretty simple. Like I said, it's a simple game. We're only going to be making it in an hour or so here. So it's going to have a little main menu, play and quit. We start the game. We have a ship. We can fly it around. We can go from one side of the screen to the other. There's asteroids that fly around, and then there's some enemies that spawn that try to follow the player. If you run into any of them, you'll die. Wait a second, you'll respawn. There's a lives counter, and then we can also shoot. Sorry if that's a little loud. It's loud on my side. So that. There's also a machine gun, and there's a shotgun implemented. So we're going to be covering how to make different types of weapons and being able to switch between them as well. If we run into them, we'll get a game over screen, give you the ending result, and then take you back to the main menu. So this is what we're going to be making today. So what we're going to do before we dive into the development is we're going to just go over a high level of the project architecture, and then we're going to dive right into the code, and I'm going to explain my thought process as I go through developing these systems for the game. Yeah, you can download processing now if you want. Here, I'll put the link back up there. You can follow along, and if you want, you can also open the project. I have a link on the next slide to the finished code, and that's fully documented with comments, so you can see how everything works, and it's explained in there as well. So that's processing, and then there is the final project as well. I'll leave that up there for a second. So for the project architecture, the first thing we're going to talk about is the game loop. So this is like the heartbeat of any game project. It's essentially a loop, and we do two things. We'll have to update the game, anything on screen, anything that depends on time, any sort of systems. Most of them need updating, and this happens once per frame. And then after that, we have to draw the changes to the screen. So this is going to be our basic high-level architecture that we're going to use here. Oh, Kyle's drawing on the screen here. I don't know how to stop that. There we go. All right. Yeah, so this is going to be the basic thing. So we're going to, update the player, then draw the player, update an asteroid, then draw the asteroid. So it's a little more complicated than that, though. So this is essentially going to be the architecture for the project. we're going to create a game class, and it's going to do two things. It's going to update, and it's going to draw. When you call update, it's going to go down to each individual system and update those and all the information needed for it. If that's where it's going to, we're going to check for collisions, we're going to create lasers and asteroids, things like that. And then it's going to go to draw, and it's going to go to each system and draw everything that it needs. And then it'll do this loop here until the game ends. All right, so let's just jump right into it then. This is going to be our sort of high-level architecture for the game. And then what we're going to do as well is sometimes systems need to communicate with each other, or they need to share data. The game class this big game class will be responsible for communicating the systems, letting the systems communicate with each other. All right, so first thing we're going to do then is jump right into it. I'm just going to close this. All right, so the first thing we do in processing is when you open it up is it will take you to the editor portion of it. First thing we're going to do is we're going to save this. Oh, whoops, it's new, not saved. There we go. So I'm going to call this, I'm going to put it in a different folder. I'm going to call it all right. So the first thing we need to do in processing is we need to say void setup. This gets called right as the start of the program, right at the start of the program. And then we have to get the window up, we have to say size, and I'm going to do 1280 by 720. I believe it's size, yeah. Yeah, so this is going to create a window with a size of 1280 by 720 right here. All right, so the next thing we need to do is we need to get something drawing on the screen. So in processing, there's a function called draw, which gets called approximately 60 times a second. So what we're going to do first is just get something drawing on screen, so we know something's happening. First thing we're going to do is we're going to clear the screen. So this will reset the background. It should be a black color now. And then just to test, we're going to draw a circle. So in processing, to do this, we just call a function called circle. We give it a coordinates. We can say width divided by 2, height divided by 2. And then, so that's the position. In processing, there are variables called width and height, and that stores the size of the screen. So we're going to say width divided by 2, height divided by 2, and just say 32. And we can see, look at that. We've got a little circle on the screen. So now we know how to, draw something on screen. Let's start creating our game. So the first thing we want to do is we're going to create a class called game. Oh, whoops, that's not what I wanted. So we're going to click here and say new tab. This will create a new file for us, and this is where we're going to put our new class. And we're just going to call it game. Oh, font? Yeah, for sure. Give me 1 second, sorry. Is that better? Awesome. Where was I? All right. So in this game, this is where we're going to be doing most of our, this is going to be that game class I was talking about in the PowerPoint. This is going to hold all of our systems that our game is going to use. So to start, let's get a couple methods in here. Like I said, we're going to have update and we're going to have draw. So in here, this is where we're going to update everything in our game, move things around the screen, and this is where we're going to draw them. So the first thing we probably want is to get a player drawing on screen being able to control it. So in our setup here, then we're going to create a global variable called game. Down here, we're going to say game. We'll do a new game. And then in this, so this draw method that's built in gets called around 60 times a second. So what we're going to do is we're going to say game.update, then game.draw. So this will make sure that update, it'll go update, and then it'll go draw in that order. One last thing we want to do is we want to pass it something called the delta time. So this is the amount of time that's passed since the last frame. And we can use this to make units, instead of working, say, with this random unit saying 300, we want to move 300 pixels every time it gets called. We can multiply this number to turn it into units per second. So we can say we want the ship to move 300 pixels per second instead of trying to play around and guess that number. So to do this, first thing we're going to do is we're going to keep a number, which is the previous time of the frame. Previous frame time. And then here we're going to say previous frame time equals milliseconds. So that gets the amount of milliseconds that have passed since the program has started. Next, in draw, we're going to say float current time. Current frame time is equal to milliseconds. So every time this gets called, we'll get a new current frame time. And then we have to get the change in the time. So we have to say float delta time is equal to the current frame time minus the previous frame time. And then right now it's in milliseconds though. So what we're going to do is divide it by 1,000. That'll turn it into seconds. And then after this, we're going to have to set the previous frame time to the current frame time. And then we can pass this delta time to our game. I'm just going to call this dt in here. So now what we can do is we can use this to move things per second. So let's just try this out here. We're going to say float x, float y, and we'll say equals width divided by 2 equals height divided by 2. We'll say 64. So we're going to draw a circle at this x and y at a radius of 64. So, and we have this delta time. So we know now when we do this that the game will draw, oh, did I forget to go clear? I did. Sorry, this just clears the screen. This will give us that black background. So now we have a circle in the middle of the screen. So we know that the width and the height is 1280 by 720. So say we want it to take 1 second for the circle to get to the edge of the screen, right? So we can say in update, we can say x plus equals the width times the delta time. So that means it'll move the full width of the screen in 1 second. But since it's in the middle right now, it should take half a second now to get to the edge of the screen. As you saw, it moved pretty quick. So that's how we're going to be moving things around. So now we can move this. So like say we wanted to move 100 pixels per second. So 100, then we multiply by this. It'll make it move 100 pixels per second. Now we can see it moves a lot slower. Good. So now we can get something moving on screen. Now let's make it so that it can move when we use input. So in processing, there's 2 methods. There's something called key pressed, which this method gets called every time you push a key down. And there's also key released. And this gets called every time you lift a key up. So what we want to be able to do though is, because right now these just get called when you push a key. So if I in my program, if I push here, I'll say print line, and then I believe it's key, right? So every time I press a key, this is the output console down here. I'll just move this up. So you'll see now, if I push a key, if I push A, you'll see down here it says A, and it's saying it twice because I'm lifting it up. So let's see. So we have key pressed, key released. So you see W released, S released. Oh, I guess this is supposed to be pressed, but you get the idea. So it happens on that. But what we want to be able to do is say something like, if is key down. So we want to know in the loop when this happens. So what we're going to do is we're going to use a data structure to take care of this for us. We're going to use a hash map. So we're going to essentially it's going to be a character in Java, which is like a key. And Boolean. So what this is going to do is we're going to be able to use this data structure to tell us at any time if a key is being pushed or not. So what we're going to do then is we got to first initialize this data structure. So we're going to do that in this top part here. We're going to say input map equals new hash map. So now that we can use the structure. And then we're going to do a few things here. We're going to say what we're going to do is every time we push a key, we're going to into the input map, we're going to take that character and we're going to set it to true. We're going to say that, yes, here, I can give you a link to the code right now. I have a finished copy already on GitHub. Give me one moment, I'll pull that up for you. Here's the link. You can find the code here. And it's fully commented, so you should be able to look through it and read to see what it's all doing. Yeah, so what we're going to say is when we push this character, we're going to set that character's value to true. And then when we release a key, we're going to set that character's value to false. So what we're going to do now then is we're going to take, we're going to create this method here, just is key down. It's not as, so what it does, it says, and it looks in that data structure and says, okay, is that character inside the data structure? If it is, we're going to say, we're going to return either true or false if it's down, letting us know if the key is pressed or not. Otherwise, we're going to return false because we haven't. So we can test that out now in our update. We can say if, we'll say is key down, and we'll pass it W. And then we can say S, A, and D. Now for W, so in processing, the origin is in the top left corner. So X is positive going this way, and Y is positive going down. So if we were to say if key W, we're going to say Y, we'll say like float speed is equal to 200. We want to move 200 pixels per second. So we'll say Y minus equals 200 times the delta time. And then similar for S, we want to go down. And then for X, we want to do the same thing. So now we should be able to move around using W, A, S, and D. Okay, cool, we can move our circle around. So now we have all of this code inside of our game class. We're going to abstract this a little more now. We're going to put it inside of a player class we can call. So let's get started with this. We're going to say player. We're going to create a new file, and we're going to say class player. It's going to have a float X and a float Y. So this is going to be holding our position. And now what we can do now, what we can do is say player, and I guess in the game constructor, you can say player, this new player, we'll pass it the position we want it to spawn at. Right. Okay. Now we can get rid of this X and Y variables because we have our player. Now we're going to want to move this input code as well. We don't want to have this inside of our player, our game here, because it only has to do with the player. So let's say player.update and pass it this. And then now we can move all of this inside of the player, get it out of our face. We can say And then we can copy all of this, put it inside of here. And then we can make speed. We can make speed a member variable of this as well. And now in our draw here, we can say, player.x and player.y. And then now it should still work, but now our game class is looking a lot simpler. Okay, so now we can move the player around. The next step, I guess, would be to get it to shoot. So we want to be able to shoot. Let's think about how we can do this. So we need to get the mouse position and get the angle between the mouse position and the player, and then create an object that will shoot towards the player, towards the mouse. So let's think about how we're going to implement this. Okay, so the first thing we need is going to be something that represents the object that we're shooting. So we're going to create a new file for a class called laser. And it's going to need a couple things. It's going to need a position. It's going to need a speed to move at. And it's going to need an angle to move at. Okay, and then we can say create the constructor for it. All right, so now we can create lasers. Just to test this out, let's create a laser just to see what happens. And it needs a position, so we'll say just the center again. And it needs a speed and an angle, so we'll say we'll move it at 400. Now let's go like 1,000 units per second, and then an angle. So we'll say pi divided by 2. So that means it should move straight up. So what we need to do now is find a way to get these lasers to move, and then for the player to be able to shoot them. So to start with this, we're going to create a separate system for the lasers to manage all of them. So we're going to say create a laser system. And this is going to have a couple things that are important for the laser. So all the lasers will be drawn with the same picture. So we're going to create an image. This one image will be used to draw all of the lasers. And then we also need a list of all of the lasers in the game. So we're going to have an array list of lasers. And then we're just going to initialize everything. And oh, sorry, I need to get my the assets for this copied over. Sorry, just 1 second. So all of the assets for this can also be found in the repository I sent in the link. No, wait, this is the wrong one. Where is this file? Where? Workshop Development Live, okay. There we go. Yeah, laser.png, okay. So this will load our image. So this system needs to do a couple things. This system will be responsible for handling everything related to lasers, movement and drawing it. So let's create a couple methods that we're going to need for it. We're going to say void update. It's going to take our delta time that we were talking about before. And then it's also going to need a method to draw everything on the screen. So if we're going to be updating all of the lasers, we need to iterate over the list of lasers. So we're going to say for, int I equals 0, I is less than the lasers dot size I plus plus. And using in here, we're going to be controlling all of the lasers. So we can see that we have X, Y, speed, and angle. So for every single laser, we're going to say, we're going to get the laser we're currently working with. We're going to say laser.x plus equals the cosine of the angle times the speed times the delta time. I got to say laser.angle. And then we're also going to have to do the same thing. With the y-axis. We're going to take the sine of the angle to start moving it along. And then when we draw it, we're going to have to do a bit of work to get it drawing here. So in processing, we want to say we want to draw it. So we can say p image or image. This function called image will allow us to draw a picture. So we're going to say image. We're going to pass the laser image. Sorry, we got to copy this loop. So for every single laser, we have to go through and draw it. So we're going to get every single laser, and then we're going to say we're going to have to draw it. Laser X, laser Y. I guess I'll say 32 by 32 for now. Okay, so now in our main class, we're going to have to go through and we're going to get rid of this laser here, and we're going to say a laser system. And this is going to be responsible, like I said, for doing everything related to the laser. So we're going to say laser system, it's new laser system. And we're going to have to say laser system.update and laser system.draw. So if we run the game, we see there's no lasers. It's because we haven't actually created anything yet. So we're going to have to be able to shoot lasers somehow. So in order to do this, we're going to have to add lasers to this list. So what we're going to do is we're going to create something that can take this list of lasers and create a laser using it. So first thing we need to do is be able to access the lasers. So now that we can get this, we're going to have to pass a laser around. Oh, the one called Asteroid Blaster on GitHub, it'll be called Space Shooter, I believe. It'll be the same name as the folder containing all the files. Yeah, no problem. Let's see, where was I? Oh, yes. So now we need to access this. So what we want is to be able to shoot lasers, right? So what we're going to do is we're going to create another file called weapon. We're going to say class weapon. So this weapon will be able to, add lasers to the system. So we need a couple of values for this. We need a weapon that needs to have access to that list of lasers. So we're going to first say it's going to contain a list of the lasers. It also needs a couple things such as float speed for this. We're going to call it laser speed. So this is going to be how fast the lasers are going to move. And then it's also going to need something called a fire rate. So how fast it can shoot. So when we create a weapon, we're going to take in a list of the lasers. So this way the weapon has access to it. Okay, and then it's actually, so we're going to need a fire rate, which is how fast the weapon can shoot. And then we're also going to need, I'm going to say, call it fire rate timer. So this is going to, let's see, fire rate time, fire rate and then a timer. So the fire rate is going to hold how long it takes to shoot a weapon again. We're going to say 0.5. So this can take half a second before we can shoot. So that's going to be our fire rate. And when we update our weapon, we're going to say this is so we can keep track of the timer, right? So we need to update the timer inside of this laser so we know when to shoot. So we're going to say fire rate timer minus equals the delta time. So this is in seconds. So this subtracts the amount of seconds that have passed. When this number is less than 0.5, then we'll give the weapon the ability to shoot. So what we're going to say is we don't want this number to be less than 0. So we're going to say if the fire rate timer is less than 0, we're just going to say fire rate timer equals 0. And then what we need to do is this weapon has to have the ability to shoot now. So we're going to give it a method called fire, or we could call it shoot, something like that. And it's going to need a couple of things. We're going to need a position for it to start at, and then for the bullet to start at, and then we're also going to need an angle for it to move. So just to start, let's make a simple weapon, one that just fires one bullet. Okay, so what we're going to have to do then is we're going to have to create a new laser. Right, now if we look back at laser, we can see it needs 4 things for the constructor. It needs an X, a Y, a speed, and an angle. So we have an X here, a Y here. The speed will be set up here. Well, let's just say the speed is equal to 1,000 for now. And then we also need an angle, which we passed as a parameter here. So we can say laser equals new laser, and X, Y, laser speed, then the angle. Okay, and then we want to say lasers.add laser. So we add a new laser to our laser system. So let's go into how this will work. We have our main game here, and we have the laser system. So what we're going to have to do now is we're going to have to somehow associate the weapon with the player, because the player wants to be able to. It's going to be the one who wants to be able to shoot, right? So to start, we're going to say player.setWeapon, and we're going to say new weapon. Oh, do it down here. Or maybe I'll separate this out. So say weapon equals new weapon, right? And what we're going to do is say we're going to say laser system.get lasers. So the weapon and the laser system will share that list. So that'll allow them to communicate. So now we have player.setWeapon. Let's go here and say void set weapon. And then we're going to go here and have a weapon. Okay, and then it creates a laser at X, Y, at the speed and the angle. So now in the player, we want to, let's see. Now in the player, we want to be able to check when we want to shoot. And then at that point, we're going to say, so we're going to do something like, we're going to say if mouse button down. Let me just double check. Where is that? Here we go. Yeah. So let's break this down. So let's create another method here just to simplify. We'll say private void do player shooting. This is also going to need the delta time. So at the bottom here, we're going to say do player shooting and pass it this time that we had before. Okay. And then we need to do a couple things. We need to update the weapon so that fire rate timer can update. And then we need to check for mouse input. So when we click, so in processing, a way to do this is if we say if mouse pressed, so this will tell us if a mouse button is pushed, and we want to check to see if it's the left mouse button. So we're going to say if the mouse button equals the left one. And then what we need to do is in here, we need to be able to get the angle between the player and the mouse. So I'm not going to go into the math of this too much, but we're going to use some vectors to make this a little simpler for us. So we're going to so we're going to create a new vector at the player x, or that's right here, I guess, x and y. So this will create a new vector at the player position. Then we're going to do the same thing and get one for the mouse position. So we can say mouse x, mouse y. And then to get the angle, what we do is we're going to do p1 minus p0. So that'll give us the vector pointing from the player to the mouse. And then we're going to use a method to get the angle between them. So we can do this by saying p1 dot sub p0. This will give us the vector from the player pointing towards the mouse, and then we can say dot heading. And that'll give us the angle between them. And then now what we can say is weapon dot fire. We can say pass it the player's x, the player's y, and then this angle that we just calculated. Okay. Let's see, weapon, laser system, draw. All right, now let's see what happens. Okay, so we can shoot, but it looks a little funky. The fire rate's not quite working. You can see that it's a little off center as well. So we'll fix this all up. So now that we can shoot, woo. So we have this fire rate that we haven't. We have this fire rate that we have to deal with now. So in fire, all we have to do is if the fire rate timer is less than or equal to 0. So we have this timer, right? And what we want to know, if that timer is less than or equal to 0, then we can shoot. And that's good. But after we shoot, we have to be sure to also reset that timer. So we can say fire rate timer is now equal to the fire rate. So now if we do this, you should see it shoots about every half second. And of course, we can adjust this too. So inside this fire rate, if we make this 1, that means it fires every 0.1 seconds or 10 times per second. And you'll see it shoots a lot quicker now. Awesome. So now we can shoot. Actually, I never tested it with moving. Let's see. Yeah, so now we can move around and shoot just fine. Let's see here. So the movement that I wanted to do is a little bit different. So we're going to change how the player moves around now. So what we're going to do is I'm going to show you the final version. So the player moves at a speed, and then you use so you can use S and W to slow down and speed up your ship. Then using A and D, it'll rotate the ship at an angle, so you can kind of turn around and then movement like this. So this is what we're going to change now. It's a little hard to tell which way we're facing using a circle. So we're going to switch it up now and have an image for the player. And we're just going to say image equals load image asset slash I think it was player ship PNG. So we'll do this, and then inside of draw, which I think I still do in game. Yeah, so we're going to do this now. We're going to say player.draw. So we're going to create another method inside of player so it can draw itself. So we'll see now if we say image, if we say at the image, our X and Y, let's give the player a size as well. We'll say size equals 64, image, X, Y, and then it asks for width and height. So we'll say size and size. So you'll see this looks a little funny. It doesn't move around quite right, and it kind of looks like the bullets are coming off center, and we got to do some rotation. So in processing, if we want to rotate an image, we have to use a little bit of linear algebra. But it's okay if you're not too familiar with that, because I'll show you how to do it here. Processing does a lot of the stuff built in for us. So if you want to rotate something, we'll have to say push matrix This will allow us to reset everything after. And instead, we're going to say translate. So this will move it. This will do the positioning. We're going to say translate by x, y. And then we're going to say rotate by the angle. But we don't have an angle right now, so we'll do that after. And then we'll say, then what we can do here is say, so what this does is this moves the image by the x and y. And then what this does is it says we want to, by default, this draws it from the top left corner. By saying negative size divided to size divided to size and size, this will draw it from the center. So now you can see, so now you can see it moves around like this just fine. Next, what we need is we need to rotate the player. So we're going to say float angle equals 0 to start. And then we'll say we need to rotate it by the angle. And then what we're going to do is in here now, we're going to say, instead of A and D moving it left or right, we're going to use this to rotate our player. So we're going to say angle minus equals, we'll say pi times the delta time. So 180 degrees per second. And similarly with D. So now if we push A and D, we should be able to rotate the player. Next, we can see here that pushing up and down still only moves the player up and down. So that's what we're going to fix next. So what we're going to do is say this is our current speed now. Then we're going to have another variable called max speed. And we'll say this is equal to 300. So now what we're going to do is I'm going to move this into its own method as well. So we're going to say do player movement and pass it the delta time. And we're going to just cut this, put it in here for now. So this angle stuff is fine. We don't need to worry about that. This is what we need to change. So if W is down, we want to make our we want to move faster. So we're going to say float acceleration is equal to the player.max speed. So this means what this is is equal to the max speed. So we're going to say this we're going to get to the max speed in 1 second. So we're going to say current, what did I call it? Speed. I'll call this current speed. So we're going to say the current speed is plus equals to the acceleration times the delta time. And then we need to make sure we're not going faster than the fastest we need to go. So we're going to say if the current speed is greater than the max speed, then current speed equals max speed. And similarly with this, we want to be able to slow down. So we can essentially copy paste this, but do it in the opposite direction. So we're going to call this deceleration. And we're going to say it's equal to max speed times 2. So that means we should be able to decelerate in half a second. Plus equals deceleration. And we can say if the current speed now is less than 0, then the current speed will be set to 0. So that'll lock it to that value. So now, did I forget to call do player movement? Do player movement. W, acceleration. Yes. So what we do is we set all these variables, but then we haven't moved the player yet. So now at the very bottom of this, we have to say the player x. We have to say x is plus equals to the cosine of the angle times the current speed per seconds. And then we have to do the same thing along the y-axis. So y and then the sine of the angle. And now we should be able to move around and rotate and shoot. Awesome. Oh, that's really fast. Why is that going so fast? Minus equals, that's what I need. Yep, so move, stop, and rotate, and shoot. Awesome. So now let's fix how the lasers look. They look a little funky right now. So we're going to do something similar to what we did with the player with this push matrix pop matrix with the translating and rotating, just to make it so that all looks right. So if we go to laser, the laser system here, we're going to do a very similar thing within this loop. Say translate laser.x, laser.y, and we're going to rotate it by the angle of the laser. And then we can say image, laser image, x laser.y. We can say the laser image width and the laser image dot height. So this, our lasers should look a lot better now. Oh, something's wrong. Let's see what's happening here. Push makes spot my laser. Oh yes, that's why. Okay, so this is right. So since we did that, since we did the translation here, we're sort of essentially moving it twice. So we have to do what I did before and say negative this divided by 2, negative this divided by 2. There we go. So that looks a lot better now. Next, we're going to need, so now we can move and we can shoot. Now we need something to shoot. So to start, let's go ahead and start creating an enemy ship. So we're going to create a new file. We're going to call it enemy. It's going to need a couple things. It's going to need a position. It's going to need it's going to need a position. It's going to need it's going to need an angle that it's moving at, and it's going to need a speed. So when we and we're going to say enemies move at 400. Why not? 400. There we go. And when we create it, we're going to need to pass an x, a y, and a angle for it to start moving at. And we're going to need to update it. And we're going to need to draw it. Similar to the lasers, there's going to be multiple enemies on the screen at a time. So let's create a system to control these enemies. So we're going to need a list of all the enemies. You'll see this is a pretty common pattern in game development. You'll have a list of something. You need to do the same thing to all of the items in the list, and then you need to pass that list to something else. This is something that'll come up a lot when you make games. So in addition to the list, we're going to need a copy of the image for the enemy. Yes, we don't need that. We can do that, and we'll say enemy image is new, or load image. We're going to need to update our system. And we're going to need to draw everything in it. So let's get the drawing out of the way, because that's very similar for all the systems. So we're going to have to loop over the list, the enemy, and me. And then we're going to have to do all the drawing for it. I will say, give it a size too. We'll say float. Okay, so now this will draw every enemy that we have. All right, and then we need to update them as well. So we're gonna get, I'm just gonna copy this. We're gonna get all the enemies. And then we need to move them. So, enemy dot x plus equals the cosine of the enemy dot angle times the enemy dot speed times the delta time. Right? So now we can move the enemies at an angle. So now if we go back to our game class, we can add our system here. Okay, and then we have to update it and then draw it. And yeah, so that's good now. So that's working, but we haven't done anything to create enemies. So what we're going to say is before this, we're going to say, spawn enemies. So this method here is going to be responsible for randomly picking a spot for the enemies to spawn. So what we're going to do is we're just going to simply spawn it on one of the edges. So we're going to say it's got a 50-50 chance of spawning on the left-hand side or the right-hand side, or a 50-50 chance of spawning on the top or the bottom. So this will let it spawn from one of the top four corners. So we're going to say Boolean left side is equal to a random. We're going to say we need a 50-50 chance. So we're going to say a random number between 0 and 1. And if this number is greater than 0.5. So that'll give us a 50-50 chance of it spawning on the left side or not. So we need an x and y for the enemy for it to spawn at. So for spawning the left side, it's x is 0. So we're going to say if left side, then the x is equal to 0. If right side, or else, we can say x is equal to the width. And then we can do something similar for the top and the bottom. So we're going to call this top. And say if y equal to 0 and y is equal to the height. Okay. And then, so we also need the angle for the enemy to move at. So we need to get the angle between the enemy and the player. So the enemy doesn't have access to that. So what we're going to do is we're going to pass the player into the enemy system. This way that it has access to it and can see where the player is at all times. And we'll simply say this player equals player. Okay, so now very similar to how we got the angle between the mouse and the player in the, where is it? Here, we can grab this and put it in here. So P0 is going to be this X and Y, and P1 is going to be the player.x and the player.y. And then now we have our angle here. And what we can say is, enemy equals new enemy. We can give it the X, the Y, and the angle we just created. Oh, I copied this twice already. Let's see. All right, and then we can just say enemies.add this enemy we just created. So now if we do this, yes, we need to pass it to the player. You can see that there's there's a lot of them being made in the wrong spot though. Let's see why. X, Y with height. Yeah, that's fine. Angle dt. P1 dot sub. Oh, P0 dot sub P1. Right. Now we want to go towards the player. Okay, X. Yeah, this should be it. Yeah, I'll call these spawn X. This is where it's spawning. And then the spawn angle. So this gets called pretty often though. It's getting called, every single frame. So we need some sort of timer to cool us down again. So we're going to say, float spawn timer equals, or spawn time equals, we'll say it can spawn every 2 seconds. Let's float spawn timer equals, we'll say spawn time to start. Very similar to how we had before. We're going to say spawn timer minus equals the delta time. If the spawn timer is less than or equal to 0, then we want to continue spawn time. So this will reset the timer. And then inside of here, we want to be able to spawn our enemies. So we'll only spawn them after the timer has gone off. We all indented one more. No? Okay. Okay, where are they at? Let me just get enemy.speed, cosine, sine, y. Why are they not going towards the player here? I guess we don't need this in here. This dot angle equals angle. That's what I missed. Sorry about that. So now when they spawn, they should come towards the player. As you can see, there they go. So the next thing we want is for them to be able to turn towards the player. So we got to adjust that angle. This moves the enemy. So before we move it, we need to adjust the angle between them. So we need to adjust the angle that the enemy is moving at, so that they can sort of follow the player. So similar to how we got the angle before, what we're going to do is first thing we're going to do is get the vector going from the enemy towards the player. So that's the that's the one that we want it to be. So this P0 is what we're trying to get the angle towards it. And then this right here is the vector representing the direction the enemy is currently moving at. And then what we're going to do is we're going to interpolate between them. So we sort of get like a middle point between these vectors. And then we're going to take that vector. So this is called linear interpolation. And this will give us a vector in between the two. And then what we're going to do is say, get this vector and get the angle of it. And then what we're going to say is that the enemy.angle is equal to this final angle. So this will allow the enemies now to, you'll see they come and they turn towards the player now. Awesome. So the next thing we want to do is get it so that we can shoot them. So we can shoot bullets, but we cannot hit them right now. Nothing is detecting collision between them. So that's the next thing we're going to create here. So we are going to create a new system. We're going to call it the laser collision system. And this is going to have a couple things for us. It's going to have a list of the laser, the list of the lasers, so we can check the collisions with them. And it's going to have a list of all of the enemies as well, so we can check between them. So when we create the laser collision system, it's going to need all the lasers, and all of the enemies as well. So we're going to say this dot lasers equals lasers, this dot enemies equals enemies. And then it's only going to have one method associated with it. It's going to have a method called check collisions. And what we're going to have to do is iterate over these lists. We're going to say for every laser, we got to check every laser, and we are going to have to check through every single enemy alongside that. J, and this is the enemies. Say and then those enemies I get J. So now we have our laser and our enemy. So we're going to be using circle collision for this. So we're gonna have to do a bit of math here to get it. So the first thing we're gonna have to do is get the distance between the two objects. So that's done using this formula here. You may have seen this in your math courses. It's just the distance between 2 points. So we the laser x minus the enemy x squared, laser y minus the enemy y squared, and then you take the square root of that. And that'll give us the distance between them. And now what we need is so we have the distance between them. And since we're using circles, we can check to see if circles are colliding by, we have our 2 circles, right? And then say this line here, that's the distance between them. So since we have the length of that line, we can tell if 2 circles are colliding if the sum of their radius, or their radii, so like this, if it is less than the if the sum of their radius is less than this distance, then we are colliding. So what we can do is call that our collision threshold. Let's see, we have size. Oh, laser doesn't have size. Let's go ahead and add that. Well, so this is going to be, we'll say that's the size for the collision of lasers. Collision system, there we go. And then what we can do is just say if the, we can say that we're colliding if this distance is less than the threshold. So what we can now do is to say if we're colliding, we want to remove the laser we want to remove the laser and remove the enemy from the game. So what we're going to have to say is we're going to have to keep a list of all of these ones we want to remove. So we can say a list of so the reason we have to do this is because we can't change the list while we're looping over it. That would cause very bad things to happen. So what we have to do is keep track of all this. These will keep track of all of the lasers and the enemies that we have collided with, and then remove them after we exit the loop. So we can say if we're colliding, we can say remove laser.add laser and remove enemy.add the enemy. Then what we can say is after the loops, we can say lasers.remove all. So this will remove all of the lasers that have collided. And then we do a similar thing with the enemies. So we say all the enemies dot remove all remove enemy. So now if we run this and we move, we should be able to shoot these guys as they come. And that's not working. Let's look at why. Enemy.size 32. And if we make this size. That's 32. 32 is a little small. Let's make this 64 maybe. Nope, they don't want to die. Oh, I know why. So we created this laser collision system, but we didn't add it to the game. So we have to say laser collision system, laser collisions, and then we have to create this system. So we say laser collisions is equal to a new laser collision system. And then it needs two things. It needs the lasers. So we're going to say the laser system dot get lasers. And then we're going to say the enemy system dot get enemies, which I don't know if I've created yet. I haven't. Okay. So what we're essentially doing is we're creating all these different systems. And then we're allowing different systems to interact by creating another system and then saying get enemies, get lasers. And that's how we're going to allow these systems to all communicate with each other. So this will leave it so our code is fairly self-contained. And then we can also extend it. So if you want to add a new system or mechanic, you can just say, enemies.get, get all the enemies, get all the lasers, and then do something with them. Or if you want to add, rockets or, a grappling hook, you can do things like that by extracting just one portion of a system out. So the code's not all intertwined. So now if we do this, after we update the enemies and we update the lasers, we want to say laser collisions dot check collisions. Laser, I spell that wrong. So now let's see what happens. And now you see we can shoot it and they'll disappear once they get hit with the laser. Let's see, okay, 8, 10, okay. So before we continue then, there's a couple more things we can implement. So in the final game, I have a couple things. So we have this mouse cursor. We have a background, we have random asteroids spawning, and we can wrap the player around to the other side as well. You see if we go down, we can come up from the top. Asteroids spawning, moving in a direction, different weapons, score, lives. So we can go ahead and implement them, but at this point, it doesn't really matter which order we do them in. Is there something that someone is interested in more than the other, or does anyone have any questions before I continue? All right, I'll keep going then. So next thing I guess we should do then is get it so that the enemies here can collide with the player. Because right now you can see they sort of fly through him and then nothing happens. So we want the player to be able to, die or, explode when this happens. So again, we're going to create another system to do this for us. So we're going to create a new one. We're going to call it the player collision system. Oh, sorry, just 1 second. So this thing will need a couple things. It's going to need a copy of the player to check for collisions with. It's also going to need the list of the enemies. And then it's going to take these as parameters. All right, so now that we've done this, now we have this, it has access to both, very similar to the laser collision system. We're gonna have to call a method called check collisions, and it's gonna have to go through and essentially do the same thing. So we're just gonna copy paste this out of here, put in the player collision system, get rid of the outer lasers loop. We don't need any lasers in here. And we're not going to need that either. So if colliding, we'll get rid of that. And we don't need this either. Okay, good. Okay, so everywhere we say laser now, we're going to say player. We can say, okay, we get the distance between the player and the enemy. There we go. And then we say if, we can say if the player size, is less than the enemy size in this threshold, then we're colliding. So what happens when we collide? Well, right now, I guess we're just going to want to clear the screen of enemies, because that's all we can really do. So we're going to say enemies.clear. So this, if we're colliding, we're just going to take this list of enemies that's shared with all of the enemy systems and just clear it. So there's going to be nothing in it. Then since we were already colliding, we can say return to escape the method. And then we got to create this inside of game as well. I need to specify the player, and it's going to need the enemy system.get enemies. So now if they run into us, okay, we can shoot them. Oh, right, we have to call check collisions, right? And okay, so you can see that the enemies now disappear, right? That's good, but we also want the player to disappear. The player has to die. So how are we going to manage this? So right now we just have a player here. So in order to do this, let's create a system that can control the player. This way we can do things like respawning it, and we can worry about all that inside of there. In addition to that, we can handle like switching weapons, things like that. So we're going to say, we're going to create a player system, and we'll do this at the top. Okay, and then we can get rid of this here, and let's go ahead and create this player system. So this player system, we're going to say it's going to have a player. And then what we're going to do is give it some variables to allow it to respawn. So we're going to say respawn time. So this is going to be, we're going to say it takes 1 second for the player to respawn after they've died. And then we're going to say respawn timer. And then we're going to do a couple things here. We're going to have to be able to get the player so it can get passed to those other systems, like how the other ones work. It's going to have update, and it's going to have draw. All right. So we need to, we're going to change how this works a little bit here. So we have all of these variables inside the player, including weapon. And, it's got all of this code in here. We got a weapon in there. And weapon also has a list of the lasers. So we don't want these to be as coupled. So what we're going to do then is we're going to take the weapon out of player, and we're going to move it just into the player system. So we're going to move weapon into there. That way we can take it out of player. Same thing with image. We don't need the image in the player. So we're going to move this into the player system as well. And then we can set the image in here, player system. And then we can also say player equals to player in here. Width divided by 2, height divided by 2. Okay, so now we have this, and we have update and draw. So at this point, let's just copy and paste this out. We're going to take all of this out of player just to simplify player. And then we're going to have to do all these variables to make sure they use the player size. Okay, so now we don't need draw in here anymore. And then for do player movement and do player shooting, we're going to take these out as well. I'm going to move these into the player system. And then all these need access to the player variables, so we're just going to add these here. Okay, and then an update now, we could say do player movement, and we could say do player shooting. Okay, do player movement, do player shooting. Let's see what else is done here. So we have that. We have set weapon, which we no longer need because that is a part of the player system. So now we can say set weapon to weapon. Okay, and now we can say player system dot get player. We can also copy this and put this here. So now we're going to use this player system to manage all of the player interactions. So now we're going to do the same thing here. We're going to say player system dot set weapon, and then player system dot update, and player system dot draw. Oh, is that wrong? I see. Okay, it's because the lasers haven't been made yet, so we just got to move this up top. There we go. So everything should work now. Now we can shoot our gun, and we should still be able to collide. Let's just test that out. Okay, so we can blow these. We can run into these guys, but they don't kill us quite yet. So that's what we're going to do now. So what we're going to need first is we're going to need a variable to tell us if the player is alive or not. And then inside of this player system, we need to we only want to do movement and shooting if the player is alive. So we'll say if the player dot is alive, then we will do these the moving and the shooting. Otherwise, let's say else, so if we're not alive, then we're gonna want to do some respawn math. So what we're gonna say is the respawn timer minus equals the delta time. And then if the respawn timer is less than or equal to 0, respawn timer is equal to the respawn time. So this will reset the timer. And then we say player dot is alive is equal to true. So what we can do now then is inside of this player collision system where we said enemies.clear, now we're going to say player.isAlive equals false. So now if we do this, get hit, player stays still for a second because if we still draw the player. So what we want to do in the player system now is just say if player.isAlive, then we draw. So we only want to draw the player if it's alive. And then one last thing before we go on to the next feature is if we do this and say I'm over here, I'll stand here, I'll die, player will respawn in the same place. So let's not have that. So what we're going to do is at this point here, in here, we're going to reset all of the player's variables. So we're going to say the player.x is equal to the width divided by 2, player.y is equal to the height divided by 2, angle is equal to 0, the current speed equals 0. So this will reset all of the variables inside the player. So when we die, we won't be stuck moving at that speed we were before, and we'll respawn in the center of the screen. And just get a couple enemies on the screen here so we can see we're all chasing them down, and when you get hit, they all disappear. All right, so that's the basics of the game done. So next let's do a little bit of work to make it look a little nicer. So the first thing we're going to do is inside of the game, we're going to need an image for the background. So we're just going to load a picture here and draw it at the back. So we're going to say background. I think it's background.png, space background.png. And then after we do this, we're going to set the size of it to be the same as the width and height of the screen, so it takes up the entire, so the background takes up the entire screen. So we're going to say resize to the width and the height. Then what we can do is in draw, we can just say image, so we can draw the image of the background at 0, 0. So now if we do this, we should have a nice space background, which we do. We've got the stars and some colors, make it look a little pretty. So now that we can die and we can kill enemies, let's add some way of getting score on the screen. So let's create a class up here. Let's call it stats. And this is just going to hold two variables for us. It's going to have an int storing the score and a number storing the lives. And to start, this will be equal to 0, and the number of lives will be equal to 3. So what we want is that every time we get hit, we want to be able to lose a life. The first thing is our game needs to have some stats. So we're going to say stats. At the top, we're going to have to create so stats equals new stats. There we go. So now we have score and lives associated with our game, but our systems don't know anything about it. So when do these change? Score changes when we kill an enemy, and then lives change when we get hit by an enemy. So that means our laser collision and player collision system are going to need access to this. So let's pass these in through here. So we're going to say stats. Then we have to update our classes constructors here. So this is for the laser system. We're going to say stats, this.stats equals stats. That way it has access to it. And then if we're colliding with laser collision, right? So this is when we're colliding with an enemy. We can say stats.score plus equals, we'll say 25. Why not? Just a number to throw out there. So let's test this out. So we need to be able to draw this on screen. I'll get rid of this for now. So we need to be able to draw this on screen. So let's do some of the UI work down here. So the first thing we're going to want to do is set it so that the, what is it? So this is a method called text align, which tells us which corner or of the text is going to be the origin. So we're going to say it is the left top. So that way, if we draw it 0, 0, it will draw going, when we enter the text, it'll go to the right and down. And that way we can say, and then we'll say text size equal to 32. Then we'll say, then we're going to draw the text. We'll take text, we'll say text score plus stats.score. And we can just say 0, 0. And that should draw it in the top corner for us. And you can see it's up there, score 0, 0. And then if I kill these guys, you'll see that it goes up by 25 every time one of them dies. Okay, awesome. So now that we have that, let's get the lives on screen as well. So let's do something similar. Let's copy this, and we're going to say lives. We're going to say stats.lives, and the Y has to be a little lower. Let's make it 64. See lives, maybe not. Let's go 34. Yeah. So now we have score and the count of our lives. So if we get hit, lives doesn't go down yet. So that's because we haven't implemented that inside of our player collision system yet. We only did it in the laser collision system. So next, let's pass this stats, the stats object to the player collision system so it knows about it. And then when we check collisions, when we set player.isLive equal false, we can just say stats.lives minus equals 1 or minus minus. So now when we get hit, we should see that the lives go down. Let's see what happens. Lives 2, lives 1. Okay, so that's going down properly now, but there's still a problem. So we have 0 lives, we respawn, we get hit, goes to -1. We don't really want that. So inside of our game, we're gonna have to control when the game is over or not. So let's do that here. We can do that in update. Simply, we can just say if stats.lives is equal to 0, then don't update the game. The game is over. We've lost. So don't check for collisions. Don't update the game because there's nothing to update. And then what we can do now is in draw, we can say if stats.lives is greater than 0, then we can draw the game and draw the score text because we know we're still in the game if we have more than one, if we have more than 0 lives. And then what we can do is we can say otherwise, we can draw our game over text. So for that, I want the text to be in the center of the screen. So we're going to align the text to the center and the center. I'm going to set the size to be pretty big. We're going to say 72. We're going to say, then we're going to draw the text using this method called text. We're going to say game over. And we're going to draw this in the center of the screen. So we're going to say width divided by 2 and height divided by 2. So let's see if this works. Oh, if lives is greater than 0. There we go. So let's see if this works now. We can shoot, we get hit, we respawn, get hit, respawn, get hit, game over. That's what we want. So let's also draw the score under it as well. So at the width divided by 2 and then the height divided by 2 plus 72 we'll say. Then let's make this text a little smaller as well. Awesome. So that works now too. Next thing we need to do is be able to restart the game afterwards. We need to be able to restart the game and go to the main menu. So let's think about how we can do that. So we have this game class that we're running in. So let's create a method in here, say called Boolean is game over. And we know the game is over if we have more or if we have 0 lives. So we'll say, so if the game is over, we'll say return stats.lives equals 0, or lives. So if we have 0 lives, the game is over. Otherwise, it's not. So let's go back to our the very start of our program here, where we did this delta time stuff. We have game.update, game.draw. So what we can do now is we created that method called game over. So what we can say is, so we have game.update, game.draw, that's fine. We could say if game.is game over, then inside here is where we can do our logic to go back to the main menu, which we haven't set up yet, but we will. In fact, let's do this right now. Let's do this in here. So we're going to say Boolean game started equals false. And then if game started, and if the game is started, then we want to be able to update the game and draw the game. Otherwise, let's draw our main menu. So we'll say, we're going to say text align. So we have in the center. I'm going to draw our title screen. Say width divided by 2, 0. We'll say 0, and then we'll top align, center top align it. And you can see it says it up there, very, very small. Should happen anyway. So let's set the text size to be a lot bigger. There we go. All right, so now we need some buttons for our main menu. So let's say void main menu. So this will do all the calculations for the main menu, everything. So the drawing and checking to see if we've clicked on things. So we're going to put this this title text in there. And then we're just going to call main menu in here. So we're going to say if the game is started, update the game and draw it. Otherwise, we're going to do the main menu work. Okay. So the next thing we need to do is draw some text. Let's move this down here. So this is going to be for our main menu. So that draws the title. And then what we're going to need is we're going to need to get, we're going to need to draw some text that we can click on to start the game. So first, let's get the X, Y, width, and height of our text. So we'll say the float for the text X is going to be the width divided by 2. The button's going to be in the middle. And yeah, so the button's going to be start in the middle of the screen. And then we're going to have to say, we're going to drop the word play at the X and the Y. So let's just see if this works. Yep, okay, so it says play right there. That's what we wanted. Next thing we need to do is be able to tell when the mouse is over top of this. So we need to get the box around of the text and then check to see if the mouse is within it. So what we're going to do is we're going to create some variables to do these calculations. It's a bit of wordy, so I'm just going to copy paste this here. So we're going to set the text size. And then what this does is it gets the width of the text we're going to use, which is play. And then it does some math here to create the box around the text. And then what we're going to do is we have to check if the mouse is within this box. So we can say if the mouse X is greater than the button X, and the mouse X is less than the button X plus the button width. So this will let us know if it's colliding with it in the X-axis. And then we also need to do this along the Y-axis. So we're gonna have to say mouse Y less than button Y, mouse Y is less than the button Y plus the button height. So this will happen when our mouse is within the bounding box around this text. So similar to how we did the shooting, where we said, is mouse button pressed? Is it left? And then did this stuff here. We're going to do something similar here in the main menu. We're going to say if the mouse is pressed and the button is left, we're going to set the game started to true. So this should start the game when we click on play now. Let's go ahead and see if this works. Click on play, and look at that. It loads up the game. That's just what we wanted. So now let's go ahead and die. I don't think we implemented that yet. So it says game over, and then it's still stuck on game over. So next thing we need to do is have a timer for the game to go back to the main menu. So we'll say game over timer equal to 0, and then float game over time is equal to, we'll say 1.5 seconds. We want to stay on the game over screen. So this is the main menu stuff. If the game is started, otherwise do main menu. Inside here, we're also going to want to do some logic. We're going to say, let's see. Let's make this final. Okay, say game over timer minus equals the delta time. And then we can say if game over timer less than or equal to 0, then let's see if game started. No, that's not what we want. We want this. If the game started, we want this in here. Sorry. We can say if game dot is game over. Then we want to do the game over timer stuff. So if the game over timer is less than or equal to 0, then we want to, if the game over timer is less than or equal to 0, then we want to go back to the main menu because it's been game over for that period of time. So we're going to reset the timer. And then we can say game started is equal to false. Game over timer equal to game over time. And then what we want to say is we have the game over, and if the game is not over. So if the game is not over, it's this here. We say else, update the game, and draw the game. Let's see what happens now. So we click play, takes us to here. Die a couple times. Black screen. So it goes to a black screen, and then it takes us to this, which is not what we want. We wanted it to still draw the game, I guess, because that's where the game over screen happens. So we want to have game.draw in both of these. Now let's try this again. Game over. Goes back to the main menu, click play. Still the game over screen. So there's one last thing we have to do is we said if the game is over, do this timer and then go back to main menu, but we also have to reset the game. So we'll say game.reset. We got to create this method inside of game. So we're going to say void reset. And this is fairly simple. We just have to reset all the stats. So we say stats.lives equals 3, stats.score is equal to 0. That should reset it. To be safe, we could also reset all the other systems. So we could call reset on all of them to make sure they're all back to normal. But I believe we take care of that when we collide. Yeah, we say enemies.clear. Yeah, that should be fine. So click play. You know, now we can shoot all of our enemies. There we go. We have game over screen. It takes us back to the main menu, and then we can relaunch the game. Now let's make the player move a little faster. Let's do fast. Say 500. There we go. Yeah, so now we can move, shoot. We have a game over screen, and enemies that can track us. So these are just some basic game development concepts, and this is how we work with systems. Is there any questions right now, or anything anyone would like to be implemented before we continue? I know it's going on a little long here, but there's quite a bit to it. The final project is something like 1,000 lines of code. Yeah, adding a second player. Okay. So I can do that. Yeah, I can show you how to do that if you would like. So essentially what you'll have to do is, it's not too complicated. So this is nice. This is why we set up the project this way with the player system. So say we wanted to have multiple players, right? All we would have to do now then is just have an array of player systems. And then the only thing we'd have to change is, if you see here, the input is hard-coded. In do player movement, we have WSAD. So what we could do is, here, I'll show you, is if we want this, we can say player system array player systems, right? And then we have a list of systems. And now essentially every time we get a player, right? Let's see, we could even do this. So we could either have an array of player systems, or we could have the player system have an array of players, or have an array of weapons, and have an array of weapons, sorry. And then we could use these to manage it. So let's just keep it simple for now. And we're going to add, if we want to have 2 players, let's do it the simplest way we can. So inside of player, now we can't assume there's 1 player, there's going to be multiple. So what we need is the input for each of them. So we're going to say char rotate left, char rotate right, char speed up, and char speed down. In fact, let's abstract this into its own little class here, and then player will have an input. And then we pass this in the constructor. Right, so we're going to say this dot input equals input. So this is just in the constructor now. So now in the player system, when we do this and we say is key down, we can say player dot is key down. This is for accelerating, so we'll say player dot input dot, I don't even know what I called it, speed up. Right, and then we can do this for this, speed up. Speed down is what I called it. This we can say rotate left and rotate right. And let's see, where is it? So we have player system, and player system creates the player. And now it needs an input. So if we want input, this new input, we can say, then where it's in player, we'll take a constructor. I'm just gonna do this quick. I'm gonna say input H, char B, char C, char D. And we're going to just set this. So this dot speed, we'll say speed up is A, speed down equals B, rotate left equals C, this dot rotate right equals D. So up, down, left, right. Okay. So up, down, left, right. So in our player system now, we can say W up, down, left, right. And then we can pass this input to the player. Cool. So now if we run this play, we should be able to use it just the same. So what if we want to add a second player? Well, just for example, in the player system, let's go ahead and do this. So we'll say player array players, and then we have to say players equals new player array. Actually, let's make this an array list so we can make it dynamic. Right. And then we'll have one, we'll say we have one player by default. So we'll say player equals new player. We pass it this input. We say players dot add player. So when we create the system, it creates our list of players, and then adds a single player to it. So now let's say now this has to get the list of players. Call it get players, return players. And now when we do all the update and drawing, we have to do it just like the other systems. So we have to say for int I equals 0. Player equals players dot get I. Okay. And then we have to do this down here as well. We have to loop when we draw it. We also have to loop through all of the players. And then close the loop. So now we have this get players, right? So we have to say get players for the enemy system and for the collision system. So in the enemy system, we have to have, turn this into an array list of players now. So players equals players. And then similar to how we looped over all of this, we now have to do the, well, maybe not for the update. So for update, it's going to be a little tricky with the enemies because right now they just locked onto one player. So for now, we're just going to say, just to keep this simple, we're going to say it only locks onto the first player. And same here. Your dog at 0, I will crash. Yeah. And here I said I, this has to be 0. So we're going to say it locks onto only the first player in the game, just to keep the enemy simple. And then for the collision system, similar to this, we're going to have to convert this to an array list of players. Same here. And then for int I equals 0, players dot size I plus plus. Oh, look, I made that inner loop j already, so that works perfectly. And then we got to get rid of this return. So one thing with how this is set up, the players are going to share lives now. But like I said, this is just a quick implementation of that. Same for do player movements. So what we're going to do now is going to say player. and then do player movement. We're going to pass it the player we're working with. So right now, it should still work fine. We can do this. And then what we can do in our game is, let's say I want to add another player. So we'll say player system. We're going to say add player, and it's going to need one thing. So it's going to spawn at the width divided by 2. The height divided by 2. We're going to pass it an input. So we're going to say like void add player, and it needs an input so it can control it. And all we have to do now is say players.add, or players.add, or I should create a new player, I should say player equals new player. It'll need the input we pass it, the width divided by 2, and the height divided by 2. And then we can say players add player. So something to note about this is there's only one mouse on this computer. So there'll be two, the way we've implemented this, there'll be 2 players, but they'll both shoot towards the one mouse when we click. So now what we can do is in the game is I'm going to say in update, I'm just going to say if, is key down, I'm going to say just R. So if we push R, we're going to say player system dot add. Did I call it add player? Yeah, add player. And it needs an input. So we're going to say input equals new input. And we're going to say, we're going to use I, J, K, and L. Or I, K, yeah, up, down, left, right. So I, K, J, L. And pass it input. And that should do it for us. So let's see what happens here. Have the one player, move, push R, adds the next second player to the screen. I'm using I, J, K, and L to control it. I hit R again, so it added another player, but it adds another player with the same controls because it's hard-coded it here. But that's how you go about doing multiplayer. Generally, what you want to do is similar to what we did, where you pass it around, except you'll pass the list of players, and then you give it a separate input that to work with, and that's how you'd manage that. All right, let's see. So we've been at it for about, I've been at this for about 2 hours now. So I think this is as far as I'm going to go with developing the actual project. The full source code to the completed one can be found on the GitHub link in the that I sent in the chat. Does anyone have any questions about game development, or if you have any ideas about projects you're going to be doing for the Jam? Do you have, if you have any questions about how you want to implement anything like that, feel free to ask. I'm going to sit around for about half an hour if anyone's interested. Yeah, so I just reposted the link for the final source code in the chat there, and that will have the you want to do versus, how you would do like 2 players playing against each other. Yeah, okay, I can do that pretty quick. Give me a moment here. I'll let me think about how we can do this. So if you want 2 players, we'd have to change our systems up a little. So we have a player collision system and a laser collision system, right? So right now, this only checks lasers against enemies. and lasers, lasers against enemies, and this checks players against enemies. So if we want to have a player versus a player, we'd have to essentially create two more systems. So we can reuse some of our code to do this. So let's go to our main game class here, and what I'm going to do is I'm going to take out the enemy systems. So we're not going to use enemies now. This is just going to be, we're going to say a player versus another player. Let's see. So if we're doing a player versus another player, I'm just going to go ahead and get rid of the enemies since we're not going to be needing them. So let's see. So we need, for the laser collision, we don't need the enemy system anymore. If we're going to do two players, what I'm going to do is I'm going to revert back to how we had it before, where we had a player system with just one player. But what we're going to do is we're going to have two separate player systems. We're going to have a player system for every player that's in the game. So we can do this, and then the player system will then take the input. No, we don't need that. Now we don't need to add a player because it's going to be one per system. We can call this player get player. And then we no longer need to loop, so we can get rid of this outer loop. Get rid of this one. And then this indentation is going to be all off now. That's okay. And then we don't need this for drawing. So each player system is going to just have one player, and we're going to have multiple player systems. And that can stay the same. Okay, do this. Go back to our main game. How does this break things? So we have a player system, and we need to pass it an input. So we're going to say new input, W, S, A, D. Okay, and then it has a weapon system. So we're going to say player 0 system, and we're going to create another player system called player 1 system. So these are going to be our two players. We're going to have these two systems to control them. So I say player 0 system. We're going to have a player 1 system that uses I, J, K, and L. Okay. And then we don't need that, so it's to add another player. And we'll say player 0 system.update, player 1 system.update. So this, and then we have to do this in draw as well. So this will be our two players. And if you want to have more players similar to before, you'd create like an array of player systems. So you'd just have to iterate through that list. But we're just doing two players to keep it simple. And let's just make sure this works. So we run it, we hit play, and it crashes. Update, draw. Did I not say equals new system? Handle draw, something to do with drawing. Let's see, player collisions. Probably something to do with that. Yeah, player collisions. Okay, so it has to do with these. So we never created player collisions, so I think that's what's causing it to crash here. There we go. Oh, made it a little further. Do player shooting. Player system.do player shooting. Okay, so it does update do player movement, do player shooting. Because we never set the weapon for the systems, right? So similar to before, we're going to need a couple things here. So we have the player system, and before we had a laser system, but now what we need to know is the lasers have to be separate because we don't want a player to shoot a laser and then he get hit by his own laser. So we're going to have two separate systems for the lasers as well. We have laser 0 system, laser 1 system, and we're going to do the similar thing here, laser 0 and laser 1. There we go. And now the reason it's crashing is because we never set a weapon for either of the players. So player 0 system.set weapon, and the weapons are gonna have to be separate as well. So they're gonna each have their own weapon equals new weapon, and then we're gonna say this one gets laser 0 system.get lasers. Because we need to keep their lasers separately. So say player 0 doesn't want to shoot himself, player 1 doesn't want to shoot himself, but they need to shoot each other. So we're going to say player 0 system.set weapon to the weapon we just created. And you can see here that it's using the lasers from laser 0. Similar to this, we're going to have to do the same thing, but with say player 1. So we're going to say laser 1 system, and I guess we can say we'll call this weapon 1 and weapon 1. And player 1 system set weapon 1. And then we need to update both the laser systems. And then we need to draw both laser systems. Play. All right, so I can move this with WASD, and this guy with I, J, K, and L. So the one moving right now is I, J, K, L. The one moving here is with W, A, S, and D. So, but you can see if I click, if I use the mouse, they both shoot in the same direction, right? So this is going to be a bit of a problem. So because there's only one mouse on a computer. So what we can do is we can change it so that we push a button and then it'll shoot in the direction we're currently facing. So we can't shoot 360 like this anymore. We'll have to aim where we want to go. To do this, it's a pretty simple change. So let's update our input. So we need a character for shooting. And we'll say this.shoot equals E. And then what we can do is inside of our player system is where we had mouse pressed and mouse button left, we can just replace this now with is key down player.input.shoot. And then we don't need this, don't need this. And then we don't need to calculate this angle anymore between the mouse and the mouse and the player, because we just need to get the player angle, the one that he's moving at, and that's the direction we're going to shoot now. So now we need to set that key. So if we go back to where we created the input, let's just say it'll be E for player 1, and then U for player 2, because it's right there. All right. So now if we do this, we go. If I move this player and I push E, he now shoots directly in front. And this player, we use IJKL to move, push U, and now it shoots in front there. Cool. So now we have our players. They can shoot separately, move separately, but now they need to be able to shoot each other. So for this, let's go. We have our laser collision system. So since we already removed enemies, let's just go ahead and delete delete a lot of this. So we need a list of lasers. And then now instead of a list of enemies, we need to check, and we have a player, or we'll have a player, and this is the player we need to check collisions with. So we'll keep the list of lasers, get rid of the list of enemies, and say player. So this is the player that these lasers can hit. So now we want to loop over the lasers. And instead of this outer loop, we can get rid of this. Get rid of one of these brackets, and then bring all this in. And then instead of saying enemy.x, we want to do all this math related to the player position and size. So we'll say player, 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 player. We don't need to worry about remove enemy anymore because there's no enemies to remove from the list. If colliding, we say player.isAlive is equal to false. Now this kind of breaks what we had with the lives on screen here. So this stats information won't be very valid anymore. So what we're going to do is we're just going to delete stats from this because we're not going to be needing it now. Okay. So we have laser collision system, gets past the player, checks. Okay, perfect. So what we need to do now in our game is we have we have our laser collision system. And then I guess we don't need the player collision system, right? We'll have two different laser collision systems. So we'll call this laser zero collisions. And this will checks the collisions between laser system 0 and player 1. So only the lasers from laser system 0 can only collide with player 1, which is held in player system 1. So we have to be sure to configure it that way. So we'll say laser 0 collisions is equal to a new laser collision system. Laser, and then we'll have to pass it we have to pass laser 0 system dot get lasers, and then the player 1 system dot get player. And then we have to do update, which we do, and that checks. Okay, we need to do the collision checks, right? So we have to update the systems, then we have to say laser 0 collisions dot check collisions. And then I'm just going to, whoops. I'm just going to do this because we're going to need this in a bit. What did I call this? And so let's see what happens. So this is player 1 I'm moving right now. Let's shoot. Oh, and he disappears, which is good. But you can see that the bullets stop when the player gets hit. The player is still there, but he's invisible, right? So what we need to do then is in our laser collision system, we can just say if the player is not alive. So if not player is alive, we'll just say return because we don't need to check any collisions unless the player exists. So now if I move this guy out of the way, do some shooting, he'll die and bullets will go through him until he respawns, right? Oh, he's respawning that's what's happening. Respawns, shoots, goes through him, respawns, can shoot, and that should work fine. And then next what we have to do is do the opposite way. So we have to create the opposite here. So we have to say laser 0 collisions. Now we have to do the same thing for laser 1 collisions. And then we essentially invert this. So we say laser 1 collisions. It's a collision system that uses laser 1's systems and the player for laser 0. And it checks for the collisions between those. And then if we just uncomment this, copy, spelled it to do it differently. There we go. We should now be able to independently move the players. So this one can move around and shoot. This one can move around and shoot. And this is player 2 I'm moving right now. He should be able to kill player 1 and they'll respawn. This player can now go over here, shoot, kill him, and they'll respawn. So that's how you'd go about implementing, say, multiplayer. You have to have your separate systems, and then you'll have to say, use these lasers and check against this player. Use these lasers and check against this player. Say you had multiple players, so like you had 4 players, 8 players, something like that. And so you'd pass it the laser 0 system, and then you'd pass it a list of the players instead of just one. You'd pass it every player except for the one that's shooting it. So that's how you do player versus player in this type of game. Is there anything else? All right. If there's no other questions or implementation details or anything no one's wondering, then you can feel free to leave. I'm going to stick around in this meeting for another 15, 20 minutes or so. So if you have any questions that come up, feel free to ask. Or I'm also available on the Discord if you want to message me. I guess one thing I could put into this multiplayer that we didn't necessarily do is you can't really tell them apart. So pretty simple so it would make it a little easier to tell them apart without changing a lot of code is we just pass a color to them. So when we create these systems, we pass it an input. Let's also pass it a color. So we'll say we'll pass this one, we'll say blue. So this is going to be 3 values between 0 and 255 that represent color. So for the first one, we'll make it blue. So we'll say like 120, 120 RGB. And then for the other player, we'll pass it red. We'll say, so make this 255 and the other's 20 or 120. So in our player system, it'll accept a color. COL. Do that, and then when we draw it, we can just say, I believe it's tint, and we pass it this color, and then at the end we'll reset the color to what it's supposed to be, the default, so it doesn't affect any other drawing in the game. So I believe now if we do this, nope, that wasn't right. Well, they are a little bit different. What if we made it way more red? What do we say? 255 made this like 10 and 10. Where am I doing this? Player system.draw. Draws a red for a second. Let's see, game, tint. I thought that's how we did it. Let's see. Might be getting the function wrong. Let's see, tint. It just takes an RGB value. Okay, so we'll say int R, int G, int B. We'll say the same thing here. And then here we can say tint RGB, and then tint 255 at the end. So now we need an RGB. We'll just pass it these values. See if this does the trick. There we go. So now we have a blue player and a red player. And if we want the lasers, so the lasers will still be the same color. So if we want to tint the lasers as well, we just have to pass these colors to the laser systems. So we could just pass this into here and this one into here. Laser system. And then tint. And at the end, we do 255, 255, 255 to reset it. So now the lasers should match the color of the players as well. All right, I'm going to leave the meeting open again for about another 10 minutes or so. Anyone has any questions, feel free to ask. Yeah, no problem. I hope this helped out. And of course, during the jam, I'll be online on Discord to chat. If you need any help with your games, I'll be here. I'll be supporting people during the jam. Me, no. Believe I was placed on Team 20. Um, I will. I can attempt. Wasn't really planning on participating. I was planning on more helping people who needed it during the jam. Um, but we'll have to see how much of a presence I'll have because I'm pretty busy and I don't know if I'm going to have time this week. I've got a lot of exams and I've got co-op stuff to prepare for as well. Yeah, it's pretty busy. I've got combinatorics and multivariable um, this week, and then I've got an econ 1010 exam, but that's just not too bad.